Hi, welcome to Anil Nair classes. Thank you for attending this live class, extremely important class. In this live class, I am going to discuss one of the most important sub-concept in number system, that is perfect squares and perfect cubes. We will be solving close to 30 plus questions only from perfect squares and perfect cubes. In case if you have not got any understanding of perfect squares and perfect cubes basics also, it is perfectly okay, because I am going to start the class right from the basics. I will start from basics and I will take you to a level where you can start creating your own questions in perfect squares. Let us not waste time. I request each and every viewer to sit in my class with a notebook and a pen. Avoid taking screenshots. That is a very wrong way of learning mathematics. Right after every problem that I solve, I will explain some important key points which I may or may not keep it in the PPT. Ensure that key points are there in your notebook. Immediately after the class is over, one time revision the same day before you sleep is extremely important, and do the same revision within 48 hours. There is a beautiful saying, anything which is not implemented within 48 hours, a new skill set can never get implemented. Immediate revision, within 48 hours do revision one more, and you will see a tremendous improvement in the way that you look at this concept. Straight away get into the class. Today's class is on perfect squares and perfect cubes. To all the students who are from a non-mathematical background, I will start with the definition of perfect square, then I will explain the properties of a perfect square, then I will also explain how to check whether a number is a perfect square or not. Same thing also holds good for perfect cube. What is a perfect cube? What are the properties related to a perfect cube? How to check whether a number is a perfect cube or not? Everything we will start with the theory. I believe in knowledge, understanding and application. KUA pedagogy is what I am going to use. First we will have a knowledge about the concept that we are using, then we will understand some important property, then we will start using the problems. Now, few important informations. This slide is extremely important to me. This is what I expect from each and every viewer who are attending my classes. At the end of the session, my objective is to make you eliminate the use of pen and pencil and start utilizing the fullest power of our brain. In case if you are taking 2 or 3 minutes to solve the question right after my class, I want you to solve the question in probably maximum time of 45 seconds. Anything that you are taking X time, I wanted to reduce it to X by 4 times. 25% of the actual time that it takes to solve a question is what I am more interested in. That's exactly the reason why I am asking you to take down every important key point in your notebook and a pen. Your notebook is your Bible. No textbook can beat the notebook which is created by you. Those of you who don't know about me, I was the ex-career launcher South India academic head. I might have taken more than 1,000 students, minimum 500 times in a class. I don't take classes in colleges, in classrooms. Almost all sessions happens in big auditorium. If the auditorium is hall capacity is less than 500, most likely I will not enter into that college, right? Watch the entire lecture. Don't quit in between. And in case if you got any doubt at the beginning of the lecture, I am sure that I might be handling the doubt in the form of a problem probably at the end of the lecture. In case if you got any doubts after watching the full lecture, kindly send us all your doubts to support@anilnairclasses.com. My team will be more than happy to take care of you. Now, those of you who don't know, we are ranked number 1 in Google reviews all over India in any of the aptitude exam online coaching. Close to 3,643 plus Google reviews are there with a rating of 4.8 out of 5. You can type Anil Nair classes reviews, Anil Nair classes Bangalore reviews in Google. You can read all your reviews. You can see what the world is talking about our content. You will come to know why we are ranked number 1 as soon as I start the content. Now, let us straight away get into the concept. Concept is perfect square and then a perfect cube. First of all, what do you mean by a perfect square? 2 square 4 is a perfect square. 2 square means 2 into 2. 6 power 4 is a perfect square, which is nothing but 6 square into 6 square. 2 is a number. A number is multiplied by itself. So 2 square is a perfect square. 6 square is a number. That number is multiplied by itself. It is a perfect square. Number, when you take a number, you take any number, multiply by itself. You take any number, multiply by itself. The power will become an even number. The power will become an even number. If the power of any number is an even number, including 0, 1 is also a perfect square, including 0, then that number is called a perfect square. Perfect square. Perfect square in simple non-mathematical language is take a number, multiply by itself. Take a number 4, multiply by 4, 16 is a perfect square. Take a number 25, multiply by itself, 25 into 25 is 625, it is a perfect square. You take any number, multiply by the same number itself, the number is called a perfect square. This is a non-mathematical definition. Mathematical definition is, if you take any number which is of the form a power x, if x is either of the form 2k or 0, 2k or 0, then a power x is called a perfect square. Then a power x is called a perfect square. Anything which is of the form a power x, if the power is either a multiple of 2 or an 0, then the number is called a perfect square. This is a mathematical definition. This is the definition of a perfect square. Some important properties related to a perfect square. A perfect square. Every key point I am going to solve a lot of problem. A perfect square means it is nothing but a natural number. A natural number multiplied by itself. It is a perfect square. Are you all with me? A perfect square is nothing but if the power is 2 for any natural number, 2 or 2k, then it is a natural number. Are you all with me? What do you mean by a natural number? Either it can be an even number or it can be an odd number. Are you all with me? A natural number can be either an even number or an odd number. Any even number is divisible by 2. So it is nothing but 2k whole square. 2k whole square is nothing but 4k square, which is 4 into some number. Any odd number is of the form 2k plus or minus 1 whole square, which is nothing but 4k square plus or minus 4k plus 1. This is divisible by 4. Any number multiplied by 4 is divisible by 4. This is also divisible by 4. So these of the form 4 into something plus 1. That means extremely important point. A perfect square will always be of the form either divisible by 4 or it gives a remainder 1. A perfect square will always take the form either divisible by 4 or it gives a remainder 1. A perfect square can never be of the form 4k plus 2 or 4 into something plus 3. Very, very important point. If a number is a perfect square, it is always of the form 4k or 4k plus 1. Any perfect square is always of the form 4k or 4k plus 1. It can never be of the form 4k plus 2 or 4k plus 3. you take a number, when you divide a number by 4, if you are getting a remainder 2 or remainder 3, then that number is not a perfect square. This is how you can check whether a numerical value is a perfect square or not. Again I am repeating, take a number, divide that number by 4. How to check whether a number is divisible by 4 or not? Last 2 digits should be divisible by 4. If after dividing by 4, if you are getting a remainder 2 or if you are getting a remainder 3, then the number is not a perfect square. I hope it is clear. Extremely important key point. With this key point, we will solve one few examples so that you will understand it. As I said, please make a note of every key point. A perfect square is always of the form 4x or 4x plus 1. Example, 1735 is 1735 a perfect square. Divisibility rule of 4 is last 2 digits should be divisible by 4. 35 is 4 into 8 plus 3. A perfect square should always be of the form 4k or 4k plus 1. It is 4k plus 3. So the answer is no. Are you all with me? Is 1567 8 a perfect square? 1567 8. Is it a perfect square? 7 8 is nothing but 4 into 19 plus 2. It cannot be of the form 4k plus 2 or 4k plus 3. So answer is, it is not a perfect square. If a number is of the form 4k plus 2 or 4k plus 3, then it is not a perfect square. I hope it is clear, right? One more example is 111 a perfect square. Divisibility rule of 4 is last 2 digits should be divisible by 4. 11 is nothing but 4 into 2 plus 3. 4k plus 2 or 4k plus 3. Right? Answer, it is not a perfect square. This is one way to check whether a number is a perfect square or not. First, we have seen the definition of a perfect square. Based on the definition of a perfect square, we found out the nature of a perfect square. Are you all with me? I hope it is clear, right? Clear? Now, a question will come. Sir, if I take 12, 12 is nothing but 4 into 3. But 12 is not a perfect square. Then how to do it? That means this first example will tell, if a number is of the form, 4k plus 2 or 4k plus 3, then it is definitely not a perfect square. If it is of the form 4k or 4k plus 1, it may or may not be. Listen carefully to this key point, and this key point should be there in your notebook. If a number is a perfect square, it should be of the form 4k or 4k plus 1. If this is true, this shall also be true. If it is a perfect square, it will be of the form 4k or 4k plus 1. Reverse may or may not be true. If a number is of the form 4k or 4k plus 1, it may or may not be perfect square. From here to here it is true. From here to here it may or may not be true. I hope the concept is clear. I am repeating it once again. If a number is a perfect square, it will be of the form 4k or 4k plus 1. All the numbers which are of the form 4k or 4k plus 1 may or may not be perfect squares. Any perfect square will never be of the form 4k plus 2 or 4k plus 3. First important key point. So there could be a confusion in terms of the reverse things. That's the reason another property. I hope it is clear. First property is clear. Second property. A perfect square never ends with a perfect square never ends with 2, 3, 7 or 8. If a number is a perfect square, it will never end with 2, 3, 7 or 8. It's a very, very simple proof. if I take a unit digit of a number, if I take the unit digit of a number, any unit digit of a number will be of the form 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. If I square it, 0 square 0, 1 square 1, 2 square 4, 3 square 9, 4 square 16, 6, 5 square 25, 6 square 36, 7 square 49, 8 square 64, 9 square 81. Anywhere after squaring, did I get 2 at the end? No. 3 at the end? No. 7 at the end? No. 8 at the end? No. A perfect square never ends with 2, 3, 7 or 8. If a natural number is ending with 2, 3, 7 or 8, it may or may not be, there is no condition like that. It is definitely not a perfect square. If a natural number is ending with 2, 3, 7 or 8, it is not a perfect square. A perfect square will never have unit digit 2, 3, 7 or 8. A perfect square will never have unit digit 2, 3, 7 or 8. Example is 54312 is 54312 a perfect square. This number is ending with 2. A perfect square never ends with 2, 3, 7 or 8. Answer is no. Is 1, 2, 3, 4, 5, 6, 7, 8 a perfect square? A perfect square. It is ending with 8. Answer is no. Then a smart student might ask me a doubt. Anil sir, what if it is like this? 1, 2, 3, 3, 2, 1, a perfect square. This is how a smart student should start thinking. Now, sir, you said two important key points. 21 is of the form 4 into 5 plus 1. It may or may not be perfect square. It is not ending with 2, 3, 7 or 8. In this kind of questions, how to solve the question? Now, if you see, a smart student might ask me this question. Is 1, 2, 3, 3, 2, 1 a perfect square? 21, last two digits is 21. It is of the form 4 into 5 plus 1. This number is not ending with 2, 3, 7 or 8. So, the first 1 and 2 are not guaranteeing us, are not giving a foolproof treatment to tell whether the number is a perfect square. Maybe, may not be is what is going on in our mind. In that cases, what we'll use is, we will use the concept 3. That is how I am going to take you to a very high level. Concept 1, drawback. Concept 2, drawback. Concept 3, then another important conclusion. In this kind of questions, how to solve. I hope it is clear. Concept 3. Concept 3. Concept 3. Every perfect square has a digital sum. Every perfect square has a digital sum 1, 4, 7 or 9. Every perfect square has a digital sum 1, 4, 7 or 9. If a number is a perfect square, it should have digital sum 1, 4, 7 or 9. If a number is a perfect square, that number digital sum must be 1, 4, 7 or 9. Again a proof. Again a proof. You take any number digital sum. What do you mean by digital sum? Digital sum is defined as the sum of the digits until a single digit is obtained. What are the single digits? 0 to 9. 0 is not possible because when you add the digits, getting 0 is a false statement. So, what are all the digital sum that are possible? 1, 2, 3, 4, 5, 6, 7, 8, 9. 7, 8, 9. Right? What is these? Suppose if I take 91. 91 digital sum is 9 plus 1, 10, 1 plus 0, 1. 181 digital sum is 1 plus 8, 9, 9 plus 1, 10, again 1. This is the set of all the numbers whose digital sum is 1. This is the set of all the numbers whose digital sum is 2. Are you all with me? This is not only for one number. This is the set of all the numbers whose digital sum is 1. Set of all the numbers whose digital sum is 2, 3, 4, 5, 6, 7, 8, 9. If I square it, 1 square 1, 2 square 4, 3 square 9, 4 square 16, 5 square 16 means 7, 5 square 25, 2 plus 5 7, 6 square 36, 3 plus 6 9, 7 square 49, 4 plus 9 13 4, 8 square 64, 6 plus 4 10 1, 9 square 81, 8 plus 1 9. We got what are all the cases? 1 4 7 9, 1 4 7 9. Every perfect square has a digital sum 1 4 7 or 9. These are all the perfect square. These are only the possible perfect squares. You cannot have 0. You take a number, divide into 9 different set. One set will have digital sum 1, second set will have digital sum 2, third set will have digital sum 3, ninth set will have digital sum 9. If I square it, what are all the possible numbers that we got? 1, 4, 7 or 9. If a number is a perfect square, it will have digital sum 1, 4, 7 or 9. Now we will answer the question which we ourselves have asked. What is the question? Is 1 2 3 3 2 1. Is 1 2 3 3 2 1. Is this number a perfect square? Is this number a perfect square? Now if you see 1 plus 2 3, 3 plus 3 plus 3 9, 9 plus 2 11, 11 plus 1 12, 12 digital sum is 3. This number digital sum is 3. So it is not a perfect square. This is how you can check if the concept 1 and concept 2 is failing. Second one is 1 2 2 3 3 4 4 4 4 4 4. A perfect square. Is 1 2 2 3 3 4 4 4 4 4. A perfect square. 1 plus 2 plus 2 4. This is 9 and it is 16, 25, 29, 30. 30 digital sum is 3. If the digital sum of a number is 3, then the number is not a perfect square. I hope it is very, very clear to you. All these key points I am going to use it in some of the toughest questions where your friends who are going to another coaching center will take 2 minutes to solve. Just by listening to an absolute conceptual clarity, I will make you solve the toughest questions in maximum 20-30 seconds of a time. You will mesmerize your friends around. Your mark scores will improve tremendously. You will take the difficult question and you will say that this is one of the easiest question. You will be one of the most looked upon individual in your friends community or in your student community where you are going for coaching centers. All I expect from you is to listen to the classes with a lot of seriousness and sincerity. I do not expect students to have extreme skill in mathematics. I expect you to be serious and sincere in every live class of mine. Just give your personal time. I will take you to a level where you can start creating your own questions. I hope this concept 1, concept 2, concept 3 is clear. Again, I am repeating these important concepts. A perfect square will never be of the form 4k plus 2 or 4k plus 3. A perfect square unit digit can never be 2, 3, 7 or 8. A perfect square can never take digital sum 2, 3, 5, 6, 8. Can never have digital sum 2, 3, 5, 6 or 8. I hope this concept is clear. 2, 3, 7 or 8. This concept is clear, right? 3 important key points. Now, few important observations. See here. Observe carefully, sir. 9 square 81. 11 square 121. Listen carefully. 12 square 144. 18 square 324. A perfect square can never end with 2, 3, 7 or 8. That means possible cases are it can end with 1, it can end with 4, it can end with 5. 15 square 225. 25 square 625. It can end with 6. 6 square 36. 14 square 196. It can end with 9. 7 square 49. 17 square 289. It can end with 0. 10 square 100. 20 square 400. Anyway, if it is ending with 0, it should always have even number of zeros. One extreme important conclusion. If a perfect square is ending with 1, tens place is an even number. If a perfect square is ending with 4, tens place is an even number. If a perfect square is ending with 5, tens place is even number. More specifically, in the case of 5, it is 2. If a perfect square is ending with 9, tens place is an even number. All the cases I am getting an even number. Only if a number is a perfect square, if a number is a perfect square and the unit digit is 6, and the unit digit is 6, and the unit digit is 6, tens place it will be odd. Please make a note, sir. Extremely important point. If a number is a perfect square, if a number is a perfect square and if the unit digit is 6 only, then only tens place will be odd. Tens place will be even in every case other than the unit digit 6. Again I am repeating, there is only one case where the tens place will be an odd number. That case is only possible where the unit digit is 6 for a perfect square. I'll take this important observation and I'll solve some questions. I hope it is clear, right? Now, all the problems are clear. Now let us solve. Take a simple solved example, then we'll get into all the problems starting basic level. If a number is a perfect square, unit digit 6, tens place odd. Now, let us take a solved example. Solved example. One easy example I will do it. X square has tens place odd number. How many values x can take? How many values x can take? 1 less than x less than 50. Again I am repeating the question. X square has a tens place odd number. Tens place odd number. Tens place odd number means that is only possible where the unit digit is 6. Tens place odd number is only possible when the unit digit is 6. What is the lowest perfect square which will give you unit digit 6? 4 square is 16. What is the next number? 6 square is 36. Less than 50 is asked. So it can be 14. It can be 16. It can be 24. Are you all with me? It can be 26. It can be 34. It can be 36. It can be 44 and it can be 46. You take all these numbers, a tens place will be an odd number. 4 square is 16, 6 square is 36. 14 square is 196, 9 is odd. 16 square 256, 5 is odd. 24 square 576, 7 is odd. 26 square 676, 7 is odd. 34 square 1156, 5 is odd. 36 square 1296, 9 is odd. 44 square 1936, 3 is odd. 46 square 2116, 1 is odd. A simple solid example based upon the concept that we discussed. X square has a tens place odd number. How many values x can take? 1 less than x less than 50. Just now we discussed tens place will be an odd number only when the unit digit is 6. So unit digit is 6. Then I took a what is the smallest natural number which on square will give you 6. 4 square 16, 6 square 36. So if 4 and 6 units digit is fixed, tens place can change 0 to 1, 1 to 2, 2 to 3, 3 to 4. Beyond 4 we cannot take because the upper limit of x is 50. I hope it is clear. So what is answer? 2, 4, 6, 8, 10. Answer for this question is total 10 values. Answer for this question is total 10 values. Idea clear, right? Now, first one. So we will solve all the problems on perfect squares first. Then we will go to perfect cubes. First one, what is the smallest number that must be multiplied with 192 to make it a 4-digit perfect square? Suppose if the options are like this. Suppose if the options are like this. For example, suppose if the options are like this. Right? Now first we will do the traditional method, then I will tell you Anil Nair classes way of solving. Method 1. How the students will solve this question. Method 1. First read the question. What is the smallest natural number that must be multiplied with 192? There is a number 192. There is a number that should be multiplied by 192 so that the answer is a perfect square. Answer is a perfect square. How students will solve this question? 192. 192 is nothing but 64 into 3 into a is nothing but a perfect square. 64 is 2 power 6 into 3 power 1 into a is a perfect square, and it is a 4-digit perfect square. So if it is a 4-digit perfect square, 4-digit perfect square means power should be an even number. Power should be an even number. Already 2 power 6 is present. Suppose if I take a value 3, k square will become 2 power 6 into 3 square, which is nothing but 64 into 9, which is 576. But the question is 4-digit perfect square, a cannot be 3. Now what we will do is, if a cannot be 3, because the power is an even number, 2 power 6 means what is the next even power of 2? 2 power 8. So extra 2 square should be there. 3 power 1, extra 3 power 1 should be there. So what is the a value? A value is nothing but 12. A value is nothing but 12. I hope it is clear. Again I am repeating it. There are 3 important key points here. A should be the smallest number. Right hand side should be a perfect square, and it should be a 4-digit perfect square. 192 factorization is 64 into 3. 64 is 2 power 6 into 3 into a is a square. Because it's a perfect square, power should be an even number. It is already even. 3 power 1 is there. So I tried taking another 3 power 1, but I got a 3-digit perfect square, but I want a 4-digit perfect square. So in addition to 3, take the next power of 2, which is an even number, 2 power 8. So extra is 2 square. If you solve this question, this is the method which is taught in your institutes. You go to any institute, right? You throw some thousands of rupees, this method is taught. This method will take, if you are little faster, it will take 1 minute to solve the question. Assume you are good in mathematics and you know factorization, you will take 1 minute to solve this question, right? Now you will understand why you should watch Anil Nair's YouTube live class method 2. Method 2. Method 1, I hope it is clear, right? Answer is 12. Method 2. Method 2. Method 2. Method 2. What are the options? 2, 5, 7 and none. Method 2. If Anil Nair classes students are solving this question, method 2. ANC way of solving the question. Why thousands of students will purchase our course? You will understand it. Method 2. There is a number. I will read the question. If I were to solve the question, I will solve like this. 192 is multiplied by a number and it is a perfect square. Because it's a perfect square, for your information, these are the exact answer option that came in the examination. A perfect square will have digital sum 1, 4, 7 or 9, which we already discussed. 1 plus 9, 10, 10 plus 2, 12, 12 is 3. 3 into a is k square. First option 2, 3 2s are 6. A perfect square cannot have digital sum 6. 3 5s are 15, 6. 3 7s are 21, 3. It is not possible. Only option left is 9. Are you all with me? Such an easy question you are trying to do by using factorization method. If there is one more than one answer option where the digital sum is giving 1, 4, 7 or 9, I know few more properties related to perfect square. A perfect square cannot end with, suppose if the option is 9, I will immediately say 9 is incorrect. Why? Because 192 into 9. What is 2 into 9? 18. 18, what is the unit digit? 8. A perfect square cannot have unit digit 2, 3, 7 or 8. I know multiple concepts related to perfect square, and I know in and out when to use, where to use, how to use, when not to use, where not to use. In case if it is 9, the given number is 192. What is the unit digit in 192? 2. 2 when multiplied by 9, 2 9s are 18. What will be the unit digit? 8. Can a perfect square end with a 2, 3, 7 or 8? No. So therefore 9 can also be eliminated. Traditional method is always there with you. In case if you want traditional methods where you can get in tons and tons of videos, in case you are spending your personal time listening to my class, hoping that I will add value to your preparation and I will minimize the number of steps in which you are solving it traditionally in my absence. My role is to make you solve maximum questions in minimum time. That too by teaching you conceptually and telling you when to use, where to use, how to use the concept. I hope the first question is very clear to you. Method 1 we solved, which will take little more time. Method 2, understanding of the concept. Every perfect square has a digital sum 1, 4, 7 or 9. Using that concept, I eliminated the 3 exact options which are there. In case if there is an option 9, you can also eliminate 9 by using the logic. A perfect square never ends with 2, 3, 7 or 8. Second question, how many numbers between 1 to 1000, both inclusive, are neither a perfect square nor a perfect cube? Neither a perfect square nor. So there are numbers from 1 to 1000. Now what are the total number of perfect squares? Total number of perfect squares. First find out which perfect square is closer to 1000. 30 square is 900 beta. 31 square is 961. 32 square is 1024. That means x is less than 32. That is the first condition. The value of x will go less than 32 if it is under a square format. So how many perfect squares that we can take? Between both are inclusive. So that means 1 square, 2 square and so on up to 31 square. Total 31 perfect squares are there. Perfect cubes. Perfect cubes, how many are there? 1 cube is 1. 2 cube is 8. 3 cube is 27. 4 cube is 64. Again, a cube is nearer to 1000. 9 cube is 729. 10 cube is 1000. So a is 10. So 1 and so on up to 10 power 3. So total here 10 values. But the question is, are neither a perfect square nor a perfect cube? That means if I can use a Venn diagram, total 1 to 1000, there are total 1000 numbers. These are the numbers which are perfect squares. Perfect squares, how many are there? 31. This circle represents the numbers which are perfect cubes. How many are there? 10. Now we require this part, which is neither a perfect square nor a perfect cube. Neither a perfect square nor a perfect cube. So this is nothing but a combination of square and cube. Perfect square and a perfect cube. How many are there? Perfect square and a perfect cube. That means which is of the form a power 6. 1 power 6, 2 power 6, 64. 3 power 6. 3 power 6 is nothing but 3 power 3 cube. 3 power 6 is 3 cube whole square. 27 square is 729. So here it is 3 power 6, which is 3. Which is 3. That means this value is 3. Are you all with me? This value will become 28. this value will become 7. So total 1000 minus of 28 plus 3 plus 7. I hope it is clear. How many numbers between 1 to 1000 both inclusive? That means step number 1, total numbers both inclusive will become, between will become from. When I say between 1 to 1000, that means you cannot take 1, you cannot take 1000. But in bracket he gave that it is inclusive. So it is as equivalent to writing from 1 to 1000. From 1 to 1000 total 1000 numbers are there. How many are perfect squares? What is the nearest perfect square nearer to 1000? 31 square is 961, 32 square is 1024. 31. So 31 squares I wrote, 1 square to 31 square. Perfect cubes. What is the nearest perfect cube nearer to 1000? Not nearest, exact, it is 10. 10 cube is 1000. So 1 cube to 10 cube. But I require neither a perfect square, not a perfect cube. This outside part. So I took a part which is the intersection of both perfect square and cube, that is a power 6. 1 power 6, 2 power 6, 3 power 6. So it is 3. Out of 31 remaining is 28. Out of 10 is 7. From total subtract these values, you will get the answer. 28 plus 3, 31. 31 plus 7, 38. So 38 means 962 you will get. I hope it is clear. It's a very simple question of finding the perfect squares, finding the perfect cubes and subtracting from the total values. Remember, it is neither perfect square nor perfect cube. From 1000 delete the perfect squares, delete the perfect cubes and also delete the values which are common to perfect square and perfect cube. Here, see, this is one such classical example. 2 power 6 is one such classical example. It is 8 square and 4 cube. There is another beautiful question. In that one, right, you will do most likely a silly mistake. Second question, very simple.